Alright, hey everybody, it's Mr. A again. We're in section 2.2 today. Chapter 2, section 2. We're talking about linear relations and functions. Alright, so let's get to the show. First of all, our objectives for today. Number one, we want to be able to identify linear relations and functions. And number two, be able to write linear equations in standard form. All right. So first of all, what is a linear relation? A linear relation is just a relation that has a straight line graph. So when you look at it on a graph, it's going to make a straight line. A linear equation is an equation that can be put in standard form. So this is one of the ways that we can tell if an equation is linear. If we can get it into this form, this ax plus by equals c, if we can get it into that form, we know it's linear, and it's called standard form. Okay, so if we can get it into standard form, we know something is linear. The other thing is a linear function. If you remember from the last section, we talked about function notation. Remember, this f of x here is really just a big y. And so if we can get our equation or function into slope-intercept form, y equals mx plus b, then we also know that it's linear. And by the way, y equals mx plus b, number one as far as the most popular equation formula. I don't know, I just made that up. All right, next. But it is very popular. Linear equations. These are some things that are considered linear. Okay, we'll talk about that. First of all, 4x minus 5y equals 16. Basically, what we just talked about was this is in standard form. This is in ax plus by equals c. So ax plus by equals c. It's in that form. In this situation, 4 is a, negative 5 is b, and 16 is c. And you might be saying right now, Mr. Anderson, I thought it was supposed to be ax plus by, and that's minus. And that's okay. Really all this means is it's really the same thing as this, 4x plus a negative 5y equals 16. So even though there's a minus in there, that is okay because we can treat it as plus a negative. So that's all right. All right, next is y equals a negative 2/3 x minus 1. Well, this is in y equals mx plus b form. It's in the right form already. Negative 2/3 is your m, or your slope, and negative 1 is b. Okay, so that is linear. Next, you might say, well, what about this one? It's missing something there. We just have y equals 1/2 x. That's an m, 1/2 is m, but there's no b. Is that really linear? The answer is yes. Really what this counts as here, this counts as 1/2 x plus 0. And so whenever we have plus 0 or minus 0, we can drop it. Likewise, if we have 0 times something, we can drop it. So this really is y equals mx plus b. Just 0 is b, and we don't have to write that. So that is linear. Here's another one, a little tricky. You go, that's y equals 5. What does that mean? Here's what that really is. Y equals 0x plus 5. So again, remember what I said about 0? 0 times x, it just goes away. So really, y equals 5. That really is slope-intercept form. So that's okay. That will be linear. That's a special situation that we're going to talk about more as we go on. And this is also a special situation, the x equals 10. This is also linear. Now, there's no y, so it's not slope-intercept form. But this kind of counts as this, x plus 0y equals 10. So you notice it's like 1x plus 0y equals 10. That's standard form. So again, 0 times anything, it basically just goes away and we just have the x equals 10. So all those things are linear. So when you see stuff like that, those are linear. It's almost easier, though, to know what's not linear. If you know what is not linear, then pretty much most everything else is. Here's our first example. 2x plus 6y squared equals a negative 25. Well, the problem here is the y squared. Whenever you have a y squared or y to the third power, y to the fourth power, not linear, okay? Second situation here is the square root of x. Whenever you have one of your variables is underneath the square root, that is not linear. Third situation, when you have, in this case, x times y. We have two variables multiplied together. That means that will make your equation or your graph not be linear whenever you have an x times y. And then in this situation, the problem here is this x down on the bottom. Whenever you have a variable or variables on the bottom of a fraction, then that will not be a linear equation either. If you have numbers on the bottom, that's actually okay, but not variables. And then the last one here, if you haven't figured it out already, just like our y squared up here, we don't like x squareds either. X squared, x to the third, any power on x will also make it not linear. So those are situations that are not linear. All right, so let's look through a few examples here, see if we can figure it out, which ones are linear and which ones are not. First of all, this is a function, g of x and y equals 3xy minus 4. What do you see there? Yes, very good. X times y, that is one of our situations that is not linear. So we'll say this one is not linear. Next one. Ooh, tricky. Wait a minute. Look at it really closely. Yes, there are fractions there, but notice the x and the y are on the top of the fraction, not the bottom. This actually will be okay. This will be linear. Remember before I said the x and the y could not be on the bottom of the fraction. So this is okay, because basically what I could do here is this. I could take this and multiply this times 6, or 6 over 1. If I do it there, I have to do it here as well. And then this 6 times 4 on this side is going to be 24. Now on this side, when I distribute 6 times the x over 3, the 3 and the 6 can cross cancel. The 3 totally goes away. The 6 will become 2. So it's going to be 2 times x. And then when you take the 6 and distribute it to the y over 2, the 2 and the 6 there will cross cancel. The 2 will totally go away. The 6 will become a 3. So we have plus 3y. And if you notice, hey, that's 2x plus 3y equals 24. I took this and I changed it into standard form. So that means, yes, this is linear. Okay? So watch out for that. Next, how about this one? Yep, you're right. Yep, that's kind of an easy one there. You notice the x to the third right there. That means it is not linear. How about this one? Now in this one, yes, there's a fraction. Before we said it was a linear, and this time it is on the bottom. So no, this one is not linear. The variable is on the bottom of the fraction, so this time it is not. And then this one, you might think, well, I don't really notice anything that makes it not linear, but it's not in standard form and it's not in slope-intercept. The key is, as long as you can get it into one of those forms. And so in this case, what I could easily do is go minus 3y minus 3y. So now I have 4x minus 3y equals 7. That's in standard form. So this is linear. Okay? A few examples there. Now let's talk a little bit more about standard form and what goes into standard form. All right. So remember what we were talking about here. We said standard form is ax plus by equals c. All this means is that a is just some number, b is some number, and c is some number. Those are just numbers, okay? And so here are the rules. For standard form, number 1, a, b, and c have to be integers. So that means no decimals, no fractions. If a was 1/3, we have to get rid of that. We have to, you know how I did on that one example a second ago, multiplied by 6? I'd have to multiply by 3 to get rid of the 1/3 to make it 1. Or if b was 0.5, I'd have to multiply by 2 to make it 1. So whatever I have to do to get rid of those decimals or fractions. And then secondly, a, b, and c, they can't have a common factor of anything except for 1. So basically no common factors. Ooh. All right, so just no common factors except for 1. So for example, if this was 4x plus 6y equals 12, these all have a factor of 2 in common. We can't have that. So this is not technically standard form. What we would have to do is divide each one of these by 2, whatever the common factor was. So now this is going to give me 2x plus 3y equals 6. That would be standard form now. Okay? So have to make sure that those numbers a, b, and c are integers. Make sure that there are no common factors. And third thing here is that we need a to be a positive number. A has to be positive. Ooh, a positive. So if it's a negative, let's say, here's another example. Let's say we've got a negative 3x plus 5y equals 10. The a number here would be negative 3. It is not positive. So all I would have to do to make it positive, just divide everything by a negative 1. What that would do is make this 3x minus 5y equals a negative 10. It's okay to have a negative here and here on the 5 and the 10. We just don't want it on the 3 out at the beginning, which is your a. Okay? So a little bit about standard form. Let's see what we can do now. We've got an equation, y equals 3x minus 9. We want to put it into standard form. All right, and then identify a, b, and c. All right, 2 ways we could probably do this. Both 2 steps, I think, and whatever way would be okay. Your first thought might be, remember, standard form is ax plus by equals c. So you think, oh, let's get this x over here with the y. Okay, if you do that, then these cancel. Now you have negative 3x plus y equals negative 9. You might go, hey, yeah, there it is. All right. Oh, wait a minute. Remember our rule about a cannot be a negative number. It's negative. So divide by a negative 1. You could also multiply by a negative 1 if you wanted to. It's the same effect. So basically that's going to make this 3x minus y equals 9. Okay, there's our standard form. So that's standard form. What's a? A is 3. What's b? Ooh, this is a little trickier, but if you look, you go, what's in front of the y? There's not a number there. Remember, if something is not there, it counts as a 1, and since there's a negative in there, b is going to be a negative 1. And c will be a positive 9. That's the number out here by itself. Okay? So that's, I'm getting better at drawing the boxes. Isn't that cool? So a is 3, b is negative 1, and c is 9. Okay? Ooh, how about this one? This one's a little trickier. We got the negative 3/10 there in front of the x. So that's going to make it harder. We can't have that in standard form. We have to get rid of that fraction. So this is what I was talking about a second ago, that we have to get rid of these fractions. Well, what can I do to get rid of that fraction? If you remember, one of the favorite things I have is multiply by the reciprocal. Okay, multiply by the reciprocal. So you're kind of going to do that here, but not really a full reciprocal. It's kind of like a half reciprocal. Okay, so whatever's on the bottom of this fraction, I'm going to multiply by that number over 1. So let me rewrite this so I got some room to work with here. Negative 3/10 x equals 8y minus 15. So if I'm going to multiply this by 10 over 1, then what happens is these 10s will cancel out. as long as I multiply by 10 on this side too. And that's really awesome. Now, the problem is, if you notice, if you look ahead a little bit and plan ahead, you notice you still have a negative 3x here. What was our other rule? We can't have the number in front of x being negative. So you know what I'm going to do? I'm going to do 2 steps in one. So instead of multiplying by 10, I'm going to multiply by a negative 10. Now, why am I doing that? The reason is that now if I do negative 10, I notice that the 10s will cancel, but also the 2 negatives will cancel. Negative times a negative is positive. So now what I have left is just a 3x. I don't have to worry about that negative and do it in another separate step later. Okay? So then when I distribute here, I'm going to have negative 80y plus 150. Okay, one more step. All I've got to do now is, let's get this y to come over here with the x, and how I do that is plus 80y. So I end up with 3x plus 80y equals 150, standard form. And so what's A? A is 3, B is 80, and C is 150. All right? Good. Last thing in this lesson today is x and y intercepts. We're going to talk a little bit about x and y intercept. An x-intercept is the point where a line crosses the x-axis. All right, so football season is just starting here, and if in football the defense makes an interception, what's happened is the path of the ball has crossed the path of a defender, and of course the defender has caught it, not just bounced off his helmet or something. But the point here is that where our line crosses the x-axis, that's the x-intercept. I'll draw a graph here in a second so you can see a little bit better what's going on. In general, that point is always going to be whatever the number is and then 0. That means that at the x-intercept, y is always 0. Whenever our line crosses the x-axis, y will always be 0 at that point. And then the opposite of that is the y-intercept. It's where our line is going to cross the y-axis, which means that it's always going to be 0 and then a number, which means that the x-coordinate will always be 0 at the y-intercept. Okay? So at the x-intercept, y is always 0. At the y-intercept, x is always 0. We're going to use that to help us graph. So here's our coordinate plane. Let's take a look at a few graphs here first of all. Let's say I've got a point here and a point about there. By the way, really awesome, I just changed a setting in here. Now I can actually draw points without that menu popping up, so I'm really excited. So let's draw a line through this. And what is this point right here? Well, it's 1, 2, 3, 4, 5, 6. It's 6 up, so it's 0 for x. Sideways it's 0, but it's 6 up, so that's 0, 6. Well, what is that point right there? That's where our line crosses the y-intercept. So this is the y-intercept. Notice the y-intercept, x is 0. Okay, what's this over here? This is the x-intercept. All right, the x-intercept, what's this point? 1, 2, 3, 4, 5, negative 5, 0. On x it's negative 5, but it's 0 up and down. So at the x-intercept, y is 0. Okay, so that's what I was talking about from before. Let me draw one more line. All right, change to red. Let's draw a line here. I'm going to go from here to like here. Okay, you get the general idea. Just pretend like that line goes through that dot right there. What's this point right here? This is the point of 0, negative 1. This is the y-intercept. Notice at the y-intercept, x is 0. This point over here that we're pretending the line goes through, that is what? 1, 2, 3, 4, for 0, x is 4, y is 0, that is the x-intercept. So at the x-intercept, y is 0. So look at the y-intercept, 0 for x. At the x-intercept, 0 for y, x-intercept, 0 for y. So at the y-intercept, x is always 0, x-intercept, y is always 0. Let's use that to graph now. Here's an equation. We're going to graph this using the x and y intercepts. So first of all, that means the x-intercept, I know that y will be 0. So I've got negative 2x plus 0. That's y. We know y is going to be 0. Minus 4 equals 0. Now I just solved this. So really, that's not necessary there. So I know that I have negative 2x minus 4 equals 0. Add 4. Negative 2x equals 4. Divide by negative 2. So that means I've got x is a negative 2. That is the x-intercept. The x-intercept is at negative 2 right here. That's negative 2, 0. Okay, what about the y-intercept? All right, the y-intercept, we put 0 in for x. So this time it's going to be negative 2 times 0 plus y minus 4 equals 0. So what I did was, again, I put 0 in here where there was an x. 0 times negative 2 just becomes 0, so we don't need it. All I've really got left is y minus 4 equals 0, so then I just add 4. So I have y equals 4. So that's my y-intercept. That means that 1, 2, 3, 4 on y, that's, whoops, 0, 4 is that point. And so those are the two y-intercepts. So since I know this is a linear equation, then I can draw a line through it. So that's how I've graphed using x and y intercepts. All right, one more. Last one. Let's do the same thing here. Remember, x-intercept, y is 0. So what do I have? 6x minus 3 times 0 equals a negative 18. I just put 0 in for y. 0 times anything goes away. So now I have 6x equals a negative 18 divided by 6. So x equals negative 3. So our x-intercept is 1, 2, 3, negative 3 on x. Negative 3, 0. How about the y? All right, on the y, now we know that x will be 0. So we put in 0 for x. Minus 3y equals a negative 18. So 0 times 6 goes away. So what I really have is negative 3y equals a negative 18. Divide by negative 3. So we say, oh, y is 6. So 1, 2, 3, 4, 5, 6. That's the point of 0, 6. And that means we will draw a line through those 2 points. And that's our graph. All right, so what we learned today was, first of all, we learned what's linear and what is not linear, the types of equations. Then we talked about standard form, ax plus by equals c, and kind of the rules to all that. And then the last thing here was finding the x-intercept and the y-intercept and then using that to graph a line. So that's what we talked about today. I appreciate you being with me, and looking forward to seeing you the next time. Bye.